ln, it automatically, it's like it incorporates that base. Imagine mixing it into some of the other ingredients so that it's a shorter way to write it. Okay, so that's all that that means. All right, so it just kind of makes the pink piece disappear. All right, and it gets kind of incorporated into the log. Okay, so then we call it the natural logarithm. Right, and we call it this the natural logarithm because e is a constant that's found very consistently in nature. It's actually super cool. It's used in the golden ratio and I believe phi, the golden number. Yeah, so we just see it over and over again. It's a constant that happens when we take ratios of values throughout nature. So I think it's super cool. All right, and part 3 here. So down here, we have a bunch of you-dos. So I will post this same paper with solutions at the bottom, but I want you guys to try to do these on your own, okay? So in part 3, we're rewriting logarithms as exponents. All right, so we're doing the same thing, but we're going backwards. So here, our base is not expressed, it's silent, which means it's going to be a 10, all right? That was written up here. Our answer is inside of here. And our exponent is on the right. So when we rewrite this as an exponent, I should get my base is 10. My exponent is 3. My answer is x. Let me see who's trying to get in. Jordan. Okay. All right, and so I'm going to do my highlighting to go back. My base was 10. My exponent was 3. My answer was x. Okay. So I'm just doing the same rearranging but backwards. So no base with log means your base is 10. Okay. So that's what that means. All right, let's see. Let's call on somebody. Jordan, are you here now? Jordan? Oh my goodness. Okay, I'm gonna call on somebody else. It seems like Jordan's having some issues. All right, Jamie. Jamie, are you here? Jamie, are you here? Okay, let me put you in the absent pile to mark that back after class. Regina?
Yes.
All right, so Regina, can you identify the 3 parts, the base, the answer, and the exponent for this logarithm?
Is the base 32?
No.
Or is it 2?
Yeah, very good. That base is 2. Jamie, I just got your solution. I'm sorry that your mic is not working. I will not mark you absent. And then what is our answer for this?
5.
So it looks like that's the answer, but remember that that's the answer.
32?
Yeah, it's 32. Okay.
Okay.
Because we're starting in the logarithm. And then what is our exponent going to be?
5.
Perfect. So if I rewrite this as an exponential function, can you tell me how it looks?
Is it 2? 5 equals 32?
Perfect. 2 to the 5th equals 32. And I'm going to highlight that so you guys can see. Perfect. Thank you, Regina. All right. Then let's see. Ruby. Ruby, are you here? Ruby? Okay. All right. Well, I'm just going to go ahead and do this next one so that we can keep it moving. We have our base here as 3. Our answer here is 8. And our exponent as 4. Oops. All right. So we're going to have 3 to the 4th power equals 81. And you guys can try these and test them, make sure they really work. We have 81. We have 3. And we have 4. Here we go. All right, and the very last one, let's see if we have somebody. Daisy, are you here?
It would be E.
Yeah, so our base is E. That's good.
To the power of 4 equals X.
Perfect, yeah. So is this guy. Power was 4. And our base is E. Perfect, thank you very much. Okay, so the natural log means we have that base E. Good job. All right, I'm impressed, guys. Good job. All right, and the last little section we're going to talk about before I let you guys go is this evaluate log expression section. Remember that your answer is the exponent when you are rewriting logarithms. So if you were given this and it asked you what this value was, we can rewrite as an exponent. So 2 is my base. I'm looking for this value, so I'm going to call it X. And I know that the answer should end up being 16. So I ask myself, 2 to the what power is 16? And I should get that X equals 4. So 4 would be my value for this. Okay, so sometimes if you look at a logarithm and you have no clue, it would be easier just to rewrite it as an exponent and see what it's really saying. So here our base is 5. We're looking for the exponent, and it's equal to 1/5. All right, remember that -1 is the power that flips things to the denominator. Okay, so -1 will go here. And for the very last one, our base is 1/2. We're raising it to some sort of power. We're asking, when will that be 8? All right, because this is a fraction, we need it to flip. So we know our X needs to be a negative number. And we know that 2 cubed is 8. So if we pick -3, that'll flip it to 8. Okay, so -3 is the solution here. You also can put this into your calculator or into Desmos, and it will show you. So for example, if we were doing that first one, we had log base 1/2. Oops. I'm going to do 0.5, so Desmos is confused. And then 8. It's not going to do this. Okay, so log base 0.5 of 8, and it will give you guys can't see it, I'm so sorry. It will give you the correct value down here on the side. Okay. What questions do you guys have about evaluating before you go? Okay, does everybody understand what we did here? Okay, so you can always put it into Desmos, but if you're asked to do it without a calculator for some reason, you can just rewrite it as an exponent to solve. Okay, so during your asynchronous time, I have these you-dos for you guys to work on. Somebody's mic is on. Let me mute everybody.
Heavy steppers, love easy.
Okay, so everybody's muted now. So for your asynchronous time, I need you guys to do this you-do. All right. Don't worry about the back for now. We'll talk about that some other time. Okay. You guys also have a quiz to do today, so I'm gonna pull up that screen real quick. So let's see. Okay, so you guys have a quiz over exponential functions. Okay, this exponential functions quiz, you have a full week to do. I set the due date for tomorrow, but I'm not going to count any points off as long as you do it within the next week. It will close next week. So please make sure that you have it done before the before I think it's set to close Monday of next week. And then you have homework, which is just a little converting half sheet. Okay, so I'll show you guys the quiz. This quiz is graded. Okay, it's 81 points. This is the chance for you to redeem any quizzes that have not done well before. You may use your notes, Desmos, and a calculator, but do not collaborate with anybody. Okay. I have a time limit, and I think I only have one submission on it, so please do your best the first time. And it's just a little quiz through Canvas, so you don't have to put anything, you don't have to write on a sheet of paper and upload anything. And then the next one is your homework. It's just a little half sheet converting exponents to logarithms and back and forth. So there's a little table on here where I have the exponential form and then the logarithmic form, and you have to go back and forth between the two. So basically what we just did today. Okay, so what questions do you guys have before you guys go ahead and start your asynchronous? Okay, guys, it's important that you guys get these assignments done because there are so many people with zeros right now. Okay, I will be posting the remediation assignments this week. I just needed to look through them for a minute, but I will post those this week and then change grades at the end of the week. So make sure that you guys get those done when I post them. But for now, just make sure you're doing the class lessons for today. So make sure you get the quiz for today done. It is a quiz grade. And also make sure that you get that half sheet done and that you turn it back in through Canvas. Okay. If you have no questions, you are free to go. Jakeem, I remember I need to change your attendance. I'm going to do that right now. I will post a completed copy of the Introduction to Logarithms sheet on Canvas so that you guys can copy it down. And if you have questions, feel free to stay after and ask. So I'll see you guys tomorrow.